Hi everybody, I'm Professor Rad, and today we're going to do a little bit of exploration. So I'm deviating from my notes packet a little bit, just to give you some motivation for what we're going to be talking about in the next video, which is something called the standard deviation. So our goal here is we want to find a measure of dispersion that doesn't rely only on the extreme values, because then if we have an outlier, it's just totally going to mess up this measure. So instead of saying how far are the two extreme values, maybe we could say how far are our values from the average on average. So if things are typically pretty close to the average, then their average distance from the average is going to be pretty small. If our numbers are really far spread out, then our average distance from the average is going to be pretty big. And I'm using the word average here, but what I mean by that is mean. So we're going to look for the mean distance from the mean and see if that tells us some more information. So I've got an example data set here to kind of walk through and see what this would look like. So the first thing, I have to find the mean. So I'm going to treat this like a sample, say. So I'm going to find x bar. So to find the mean, remember we add everything up. So in this case, we get 315. And then we'll divide by however many numbers are in the data set. So we have 5 numbers here. So 315 divided by 5 is going to give us 63. So my idea here is I want to find how far are these numbers from the mean on average. So to see how far the number is from 63, I'm going to subtract 63 from each of these numbers. So I'm going to do 22 minus 63. So 22 is 41 below. Then I'll do 38 minus 63, and that's 25 below. Oh, 63 minus 63 is 0. 90 minus 63 is 27 above. And 102 minus 63 is 39 above. Okay. So I'm going to call these my deviations. It tells me how far the value deviates from the mean and in which direction. So 22 deviates from my mean by being 41 below, whereas 90 deviates from the mean by being 27 above. I want to find the mean of these deviations because I want to know, on average, how far do the numbers differ from the average. So now I'm going to find the mean of these deviations. So I'm going to say the mean of the deviations. So I'm going to add all of the deviations up. I get 0 out of 5, which is 0. Okay, so here's what that would mean. That would mean, on average, the numbers are the same as the average. And that's really not true here, right? 63 was the same as the mean, but these other numbers are really different from 63. Right? This one is 41 away, so I wouldn't say it's an average of 0 away. So here's the problem with this method. This is always going to happen. No matter what data set you have, no matter how close the numbers are or how far away they are, what ends up happening is these negative numbers end up canceling out with the positive numbers, and you will always get 0 as your mean of deviations. So this is a good idea to find an average distance from the average, but in practice it ends up not working so well. So mathematicians had to make a choice rather. They were thinking, okay, well, there's something I could do here. The problem is that these negatives and positives don't play nice. So I could just make everything positive, right? And just say like the absolute value of the deviation, add those up, divide by however many there are. But the problem with that is that a lot of the more advanced formulas we're going to be using, some of the more advanced statistics, relies on calculus. And calculus and the absolute value function don't play nice together. They're just not friends. So there's another way in math that you can take a negative and make it positive, and that's by squaring. So instead of making each of these numbers positive just by removing that negative sign, we're going to square all the deviations, add them all up, divide by however many there are, and then square root in the end. So that's going to lead to kind of a terrible looking formula, but this is the idea about why that formula exists. And that's because the squaring function plays better with calculus. It's a little bit nicer than the absolute value function. So if you want to blame somebody for this horrible formula, blame calculus. So I'll see you in the next video for the formula. Don't worry, we will make it through. It's not, the worst thing in the world, but it is seemingly overcomplicated for what we want. And it has to do with these negatives canceling out with these positives. So I'll see you in the next one. And in the meantime, have a great day.